Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about features of Pentium processor and branch prediction technique. Here, before going to the features of Pentium processor, first we should know what are the features of 80486 microprocessor and what made advancements in the Pentium processors compared to 80486. Generally, here this 80486, 80386, 80286, all these are the advanced microprocessors. After this 80486, 80586 microprocessor has come into existence. After 80586 microprocessor and 80586, from 80586, whatever the processors that have evolved, we call them as Pentium processor. So that is why 80586 is a Pentium processor. So before going to the features of 80586, that is Pentium processor, first we should know what are the features of 80486. Next we will discuss about the branch prediction technique. That means what are the issues that are there in the pipeline mechanism, and by using this branch prediction technique, how that issues can be overcome. Now, so first coming to the features of 80486 microprocessor. So if we see the features of 80486, some of the features will be advanced compared to the previous processors, that is 80386 and 80286. Depends on the size of the data bus, address bus, memory, and also depends on the architecture. All the advancements will be there in this 80486 compared to the previous processors. Here are some of the features of 80486. So 80486 microprocessor is the improved version of 80386 microprocessor. Now, so the data bus size available in 80486 microprocessor is 32-bit data bus. So it can perform all the 32-bit arithmetic and logical operations. Next, so address bus size is 32-bit. 32 address lines will be there. The address lines will be from A0 to A31. And whatever here the data lines and address lines, we are saying 32-bit, each of 32-bit. All the data lines and address lines are not multiplexed. All of them are demultiplexed. That means different address lines will be there and separate data pins will be there in the pin diagram of 80486 microprocessor. So here the number of address lines are 32 and number of data lines are 32. So in the pin diagram of 80486, address lines and data lines are not multiplexed. So here multiplexing means generally single pin functioning as two functions. But in this case, that is 80486, all the signals are not multiplexed. Now, so the physical memory size is 4 GB. Because in order to know what is the size of the physical memory, you have to consider here the size of the address bus. So we have to write the size of the address bus is 32-bit, 2 power 32. And it leads to the size of the physical memory of any microprocessor. And so the next features are here. It consists of 8 kilobyte of cache memory, and also it consists of one coprocessor. That means 80486 also consists of one coprocessor. So what is the coprocessor for this 80486 microprocessor is? Here 80387 is the coprocessor. That means in the CPU, along with 80486 microprocessor, we will have additional processor which is called as coprocessor that performs extended arithmetic and logical operations. In this case, the coprocessor present is 80387, which performs the arithmetic and logical operations. And so here, as we have seen in the features, this 80486 consists of 8 kilobytes of cache memory, we should know first what is meant by cache memory. Okay. So here this cache memory, if any instructions that we are going to use very frequently, if that instructions are placed in this cache memory, it is very easy to access that instructions whenever required. So that is the main purpose of using this cache memory. Okay. So here what is meant by cache memory means you can call this cache memory as supplementary memory. So this cache memory can also be called as supplementary memory. Why? Because here it stores data temporarily. So it stores data temporarily. So what type of data it is going to store means it stores the data temporarily, which is frequently used instructions, which are frequently used instructions or data. Okay. So why this is used means for quicker operations of CPU. So for quicker operations of CPU. So why? Because if there is any request coming, that request can be accepted by simply searching the instructions or the request that is available in this cache memory. Okay. So if any request, that request can be served faster. Okay. So if cache memory is involved, this is the main advantage. So that is why here 80486 is advanced compared to 80386 because it consists of 8 kilobyte of cache memory in the architecture. And here it is also saying along with 80486 in the CPU, it also consists of 80387 microprocessor as a coprocessor. So next we should know what is meant by coprocessor. So coprocessor is an additional processor which is involved in the CPU along with the main processor, and it will perform some extended arithmetic operations. Okay. So since the work is being shared by the two processors, the speed of operation will be high. So that is the main advantage of having coprocessor inside the CPU along with the main processor. So here coprocessor means it is a additional processor. It is an additional processor used in some computers. So it is an additional processor used in some computers to perform some specialized tasks. So what are the specialized tasks means? Here it may be some extended operations. Okay. So the specialized tasks may be extensive arithmetic calculations. Okay. So what is the purpose of having coprocessor inside CPU along with the main processor means the advantage is here speed of the processor increases. Okay. So here the main advancements in 80486 compared to 80386 is it is having cache memory. But whereas this coprocessor is present for 80386 also, and it is available in 80486 also. So this is the main advantage of having cache memory and coprocessor. Now, so coming to the next feature, it executes many instructions in one clock period, and it also executes a few new instructions that also controls the internal cache memory. So some new instructions are also there in order to control this cache memory. And so 80486 microprocessor has BIST. So here BIST stands for built-in self-test. So here BIST means built-in self-test. That means machine testing itself. Built-in self-test means machine testing itself. So here what is meant by BIST means, here BIST stands for built-in self-test, and it is a mechanism So it is a mechanism that permits the machine to test itself. It is a mechanism that permits machine to test itself. So that is why it is called built-in self-test. So here this 80486 microprocessor has built-in self-test capability. Now, so here built-in self-test means the microprocessor will test itself. What are all the things it is going to make the test means? It is going to check the microprocessor. It also checks the coprocessor that is available inside 80486, and it also checks the cache unit during reset time. So that is the main advantage of having BIST, that is built-in self-test in 80486 microprocessor. And for example, during testing of this 80486 microprocessor, if this 80486 microprocessor pass the test, then it is going to insert the value 0 in EAX register. Okay, so this EAX means E stands for extended and AX is a accumulator. It is a 32-bit register. When this 80486 passes the test, this EAX register, 32-bit register, will be filled with zeros. Now, so 80486 is available in different types of pin packages. So it is available in 168 pin, which is called pin grid array package. And this 80486 microprocessor also consists of some additional test registers. Here, those test registers are used for testing this cache memory. Now we will see what are these additional test registers that are available inside this 80486. So here the additional test registers that are available are, one is TR3. Okay, TR stands for test register. Another one is TR4 and another one is here TR5. So this TR3 is a test register which is going to test this cache unit, and TR4 is one test register which is used to test this cache status, and TR5 it tests cache control. So all these are the three additional test registers that are available internally. So cache unit is additional unit that is present inside the architecture of 80486 microprocessor. So generally, if you consider 80386 microprocessor that has been there before this 80486, it consists of different units in the architecture. So what are different unit means? It consists of bus interface unit. So it consists of bus interface unit, and next it consists of instruction. It consists of instruction prefetch unit. Totally this 80386 consists of 6 units. So bus interface unit, instruction prefetch unit, and also it consists of control unit, and execution unit. Okay, and the next two important units, segmentation unit and paging unit. So all these are the 6 units that are there in the 80386 microprocessor. But here in 80486 microprocessor, along with these 6 units, 2 units are additional. So here what are the 2 units means, as we have told already, in order to perform all these operations, along with this you also have cache unit. Okay, So based on the execution point of view, it also consists of one more unit in the architecture, which is called floating point unit. Okay. So here, this is the additional unit. Cache unit is the additional unit that is available in 80486 microprocessor. Along with the cache unit, all these units that are available in 80386 are also present. Now, so up to here, these are the features of 80486 microprocessor. Now, next comes features of Pentium processor. So, features of Pentium processor means after 80486, 80586 come into existence. So, this 80586 and all the remaining processors generally we call as Pentium process. So, here the features of Pentium process generally some of the features are advanced compared to 80486. So, the advancements here are regarding the number of memory banks that are available, regarding the architecture point of view. There are some advancements in the Pentium process. So, here coming to the memory banks of Pentium. So, here Pentium consists of totally 8 memory banks. So, here 8 memory banks are bank 0, bank 1, bank 2, bank 3, bank 4, 5, 6 and 7. So, this Pentium microprocessor consists of totally 8 banks. So, these 8 banks will be driven by one signal which is called BE signal. So, here this BE signal is also separate for each memory bank. So, for bank 0 you will have BE0, for bank 1 it is BE1. Similarly, as go on for bank 7 it is BE7. So, here this BE is the bit which is going to select the memory bank in the Pentium processor. So, here what is BE means? BE stands for byte enable. So, if this is an active low signal, if that signal is activated, then particular bank among 8 banks, particular bank, whatever, if BE signal to which bank it is enabled, it is active low signal, that particular bank will be selected. And coming to the next feature of Pentium, it is regarding execution units. So, if we take here the execution unit of this is 80486. Okay, coming to the architecture again, what are the advancements we have done in the Pentium processor regarding execution units means? In 80486, we have only one execution unit and that is capable of performing operations on 32-bit only. But here in the Pentium processor, coming to the execution units, here we have 2 execution units. 2 execution units are available here. So, each execution unit is going to perform 32-bit operations. So, this execution unit 1 is going to perform 32-bit operation and this is execution unit 2 which performs the another 32-bit operations. So, totally the 64-bit operations can be done by using this Pentium processor. So, this is also the main advancement that has done from 80486 to 80586, that is Pentium process. And coming to the same execution unit internally, so here generally this Pentium processor supports 2-level pipeline mechanism. Before Pentium process, we have only single pipeline mechanism. But here in the Pentium process, 2-level pipeline mechanism is possible with the help of 2 pipes, U pipe and V pipe. So, here this is V pipe and U pipe. So, coming to here, as we know, the additional unit that is available in the architecture of Pentium processor is cache unit, which consists of instruction cache and next one is here instruction prefetch and here 2 decoders are present. It comes under decoding unit and Next one is coming to execution unit. Here we have different execution units. So these are the two units that perform operations on integer. Two-level pipeline mechanism in order to have. Each one is having its separate pipeline mechanism. One is V pipe, another one is U pipe. And it is also capable in the features of Pentium we have seen. It is also capable of performing operations on floating point. So with the help of this FPU, which is called floating point unit. Okay. So this is the execution unit advancement that has been done compared to the previous process. And here all these things will be stored in this data cache, which is called cache memory. Now, so those are the architectures that are made advancements in the Pentium process compared to the previous process. Coming to the same features of Pentium process continuation. So the improvement over the architecture found in 80486 microprocessor. Just we have seen the diagram. It consists of only one execution unit in the architecture, and also it does not consist of floating point unit as well as cache unit. But here in 80486, it consists of floating point unit and cache unit. So the improvement over the architecture of 80486 has done in the Pentium processor. And this Pentium process are compatible with 8086, 80286, 80386 and 80486 microprocessors. That means if you wanted to use the instruction set and all related to 8086, 80286 in order to write the programming, we can use the same instruction set for Pentium process also. That is why it is compatible with the previous process. Now, so it has all the features of 80486. Along with that, all the features, it is also having some additional enhancements. So regarding number of memory banks, regarding architecture, all these are some of the additional enhancements that has done in 80486, which has led to the Pentium process. Now, so here we have seen just the features of 80486 microprocessor, what is the data bus size, address bus size, what is the physical memory size and all. Now coming to the Pentium process, all that features will be advanced. So here this Pentium processor is having 64-bit data bus. So here in this 64-bit data bus, 8 bytes of data information can be transferred to and fro from the memory in a single bus cycle. And so it supports burst read and burst write back cycles. So here, because it is supporting this burst read and burst write, so when it is supporting this burst read and burst write means, when this Pentium processor is operating in the burst mode, it is going to perform this burst read and burst write back cycles. So first we should know what is meant by this burst mode. Okay. So here burst mode means transmitting the data. Here transmitting the data repeatedly without going through the condition every time. Without going through all the steps required, to transmit each piece of data, in separate transaction. Okay. So what is the importance of operating this Pentium processor in the burst mode means? So since it is not checking repeatedly all the steps that are required to transmit each piece of data, automatically the speed of operation will be increased. Okay. So here the main advantage is increases the increases the throughput of data transfer. So that is the main advantage of operating this Pentium processor in the burst mode, that is burst read and burst write cycles. And next advantage is here. So next advantage is here it supports pipelining. As we know here, what is meant by pipelining? Pipelining means instructions will be executed in the overlapping manner. Okay, instructions execution will be done in overlapping manner. Overlapping of instructions. Overlapping of instructions during execution. Okay, so this Pentium process also supports pipeline mechanism. And so another features of Pentium processor is instruction cache. So as we have seen in the architecture, cache unit is available. So the instruction cache size, it is 8 KB of dedicated instruction cache that is available. And also the architecture consists of 2 integer execution units. We have seen which consists of V pipe and U pipe. And also it consists of another unit which is called FPU, that is floating point unit. And so here it supports pipeline mechanism, but especially it is supporting 2-level pipeline mechanism. And next feature is it consists of 256 lines between the instruction cache and prefetch buffers. That is why it allows 32 bytes to be transmitted from cache to the buffer. And next feature of Pentium processor is data cache. And same here, 8 kilobyte of dedicated data cache gives data to the execution units. And it also consists of 32 byte lines. Another feature is 2 parallel integer execution units are available. So we have seen in the architecture 2 units, ALU units are available. So it allows the execution of 2 instructions to be executed simultaneously in a single processor cycle. So speed of operation will be increased. And another feature is floating point unit. So it includes one more unit along with the 2 execution units, which is called floating point unit. So it is going to perform faster internal operations. And local advanced programmable interrupt controller is also available in this floating point unit. So here speed of operation will be increased up to 5 times compared to the normal operations, and it is applicable for instructions like arithmetic, multiply, load, store that are available in the instruction set. So compared to 80486, in order to execute these instructions by Pentium processor, the speed of operation will be 5 times greater than 80486 because it is having different execution units. And next feature that is present is in the Pentium processor, branch prediction logic. So here, to reduce the time required for the branch caused by the internal delays, this branch prediction logic can be used. We will see what is meant by branch prediction logic. So when this branch prediction logic is used, microprocessor begins prefetching the instructions at the branch address. So no instruction execution will be wasted. That means estimating the condition before its actual appearance. So here another features of Pentium process are data integrity and error detection. And so it has efficient error detection and data integrity capability. And data parity checking is done. And this data parity checking will be done byte by byte basis. And so it also consists of address parity checking and internal parity checking features. Next feature is dual integer processor. So here we have seen in the architecture, it is having two execution units related to integer execution and one unit related to floating point. So here coming to the dual integer processor. So it allows execution of two instructions per clock cycle. And other features of Pentium processor are functional redundancy check. So generally here, what is the general meaning of redundancy means? Having more than required. Now we will see here, to provide maximum error detection, the processor, to provide maximum error detection of the processor and interface to the processor, this functional redundancy check is very used. A second processor checker is used to execute in lockstep with the master processor. So that is also the advantage of this redundancy check unit. It checks the master output and compares the value with the internal computed values. Now, so when it is going to compare the value with the internal computed values, there may be a chance of having error generated. So during comparison, if any mismatch occurs, in that case, the error signal will be generated. Now, another feature of Pentium processor is Superscalar Architecture. So it is having Superscalar Architecture. So we have seen it consists of two execution units related to integer and one execution unit related to floating point. That is why totally 3 execution units are there. That is why based on the architecture point of view, we call it as a superscalar architecture. So 3 execution units. Among the 3 execution unit, one execution unit executes the floating point instruction, whereas the remaining 2 execution units will be performing operations on integer instructions. So the 2 execution units here, one is having U pipe, another one is having V pipe. These two only will be supporting the 2-level pipeline mechanism. And so parallel execution of several instructions with the help of these U pipe and V pipe. That is why we call it as a superscalar processor, because the architecture is called as superscalar architecture. So those are the features of Pentium process. Now we have to discuss about branch prediction. Now, so generally, what is the main purpose of going for this branch prediction technique means, when we write an assembly language program, if it consists of normal instructions, then when those instructions are executed in the pipeline mechanism, problem will not arise. Like if first instruction is executed, it will be execution based on the 3 sequential instructions like fetching, decoding and executing. When the first instruction is fetched, next cycle it goes for the decoding. When the first instruction is decoding, the second instruction will be fetched. When the second instruction comes to decoding, the first instruction goes to execution. Okay. So the procedure of executing the instructions will be normal in the pipeline mechanism. For example, in that program, if any branch instruction occurs, in that case, when the processor executes that branch instruction, the entire pipeline process will be changed. The entire pipeline process will be changed. So at that conditions, this branch prediction technique is very useful. So in order to avoid the problems in the pipeline mechanism, we are going for one technique which is called branch prediction technique. So first we have to know here what is meant by branch prediction. So here prediction means predicting the branch before its occurrence. That means before itself we should know to where the control has to move. Okay. So how we can know this before itself means by seeing the history of the bits. Okay, so branch prediction means predicting the result of branch instruction. Predicting the result of branch instruction is called as branch prediction. So here, this branch prediction is of two types. Okay, so static branch prediction and another one is dynamic branch prediction. So out of these two, generally the static branch prediction is not preferred. This dynamic branch prediction is only preferred. So here we have learned about the features of Pentium processor. Here the Pentium processor will take this dynamic branch prediction only. It is not going to prefer the static branch prediction. So here what is meant by this static branch prediction means, so here predicting the branch condition, will not satisfy and it continues to fetch the next instruction of branch condition. Okay, so here static branch prediction means predicting the branch condition will not satisfy and it continues to fetch the next instruction of branch condition. We will see with an example. And here what is meant by dynamic branch prediction means, here depending on the execution history bits, execution history of the branch. Okay, so depending on the execution history of the branch, prediction decision changes. Okay, so this type of approach is called as dynamic branch prediction. So based on the history of the previous bits, the branch prediction decision will be changing every time. That is why it is called dynamic branch prediction. Next, so here coming to the static branch prediction. So in this case, how the instructions will be executed means, so for example, if we consider here, this is the clock cycle consists of 1, 2, 3, 4, 5, 6, 7, for example, and these are the instructions. Okay, so for example, consider some instructions like I1, I2, I3, I4, so on up to IK. So if all these are the instructions here, if we consider, so if these are the instructions, we will see how in the static branch prediction, the execution process occurs. So if when the instruction I1 is executed, for example, consider the I1 instruction is having compare instruction and this I2 instruction is having jump instruction, which is called as branch instruction. So here up to the compare instruction, when this I1 is executed, we know it is going to take the values like first fetching, next decoding, and in the next cycle it goes for executing. But when this I2 instruction is also executed, in the first cycle it fetches the instruction, next it goes for decoding, and when the third instruction is decoding, this I3 instruction will be fetched here. When this I2 instruction will be executing, this I3 instruction here will goes for decoding. When this I3 is in decoding position, this I4 will be keep fetching. But when this I2 instruction comes into the execution position, then it will know that the branch has to be occur. That means the control has to move to this somewhere instruction where the branch has to move. So in these two cases, what happens means these two instructions will be suspended. So even though these two instructions are not required, they will be fetched, decoded, and in the I4 instruction also will be fetched. But when this when this I2 instruction comes into execution position, then only the processor will know that the branch has to be occurred. So in such cases, these two bits should be suspended. So it is waste of time. That is why the static branch prediction is not preferred, but dynamic branch prediction is preferred. So here this dynamic branch prediction can be done in 1 bit or with 2 bits also. So here if the dynamic branch prediction means, you can consider here the 2 bits. So this is an example for 1 bit branch prediction. So you can consider here this is LNT bit and this is LT bit. Okay. And this is LNT bit and this is LT bit. So LNT stands for likely not taken, whereas LT stands for likely taken. Now here this is BNT, BT. So BT stands for branch taken and BNT stands for branch not taken. So for example, assume the control is first in this LNT state. Okay. So when it is in the LNT state, if it is not having, if the branch is not taken, what happens means it will be in the same state. Okay. So if a branch is taken, then it changes the state from LNT to LT. BT represents here branch taken. Now, in the second case, if we consider here the control is at LT, that is likely taken. In this case, if the branch is taken, the control will be in the same condition, same state. If the branch is not taken, the control will move from LT state to LNT state. Okay. So based on this bits history only, this dynamic branch prediction will be done. Now, so here as we have seen in the previous example, in the dynamic branch prediction, so this LT bit stands for branch is likely to be taken and LNT stands for branch is not likely to be taken. So that is how the branch prediction technique will be operated under 0 bit. So this Pentium process supports this branch prediction technique. So the Pentium processor includes this branch prediction logic because it is having a 2-level pipeline mechanism. It has to be maintained properly. So it includes this branch prediction logic. So in order to avoid the pipeline problems, it has branch prediction logic. So it currently predicts whether or not the branch will be taken when the branch instruction is executed. Now, so when the branch operation is correctly predicted, no performance penalty is incurred. That means some of the instructions will not be suspended if the branch prediction is done properly. Now, so when branch prediction is not correct, at that time the 3-cycle penalty will occur if the branch is executed in U pipeline. And for example, if the branch is executed by using V pipeline, a 4-cycle penalty will occur. Okay. So if the branch exists properly, no problem. If the branch is not predicted correctly, these type of problems will occur in U pipe and V pipe, because these are the two units that are going to perform pipeline execution. And so the prediction mechanism is implemented using 4-way set associative catch with 256 entries. And so that point is referred as branch target buffer. Simply it can be indicated as BTB. So BTB stands for branch target buffer. So the directory entry of each line consists of valid bit and history bit. So what is meant by here valid bit and history bit means a valid bit indicates whether or not the entry is in use, whereas the history bits indicates how often the branch has been taken each time that it entered the pipeline before. So this valid bit and history bits, these are the bits that are preferred during branch prediction before the branch happens. And another one is the source memory address that branch instruction was fetched from. And so here the history bits can indicate one of the 4 possible states. Here the 4 possible states are, depending on the history bits only, the branch prediction will be performed. Here this history bits depends on 4 possible states. One is strongly taken, one is weakly taken, weakly not taken, and strongly not taken. So these are the 4 possible states. So if we are considering here 4 possible states, we have to discuss about the 2-bit branch prediction technique. So here this is the 2-bit branch prediction techniques, and here are the 4 states: 1 1, 1 0, and 0 1, and this is 0 0. So and the 4 states are here strongly not taken, weakly taken, and weakly not taken, and strongly not taken. So in this here the H represents history bit, and whereas the P represents prediction bit. Okay. So if the history bit is 1 1, okay, and here the prediction is taken, the branch will be, that means the branch will not be taken, it will be in the same state. Okay. Now if it is not taken, if the branch is not taken, it will be going to the next state. The next state is here weakly taken. Okay. So based on these 4 states, the branch prediction will be happening. So if you see here, this is the table which clearly indicates that 2-bit branch prediction technique. Here these are the 4 history bits we have seen: 1 1, 1 0, 0 1, and 0 0. So these are the 4 history bits. Okay. And next is resulting description. So what are the 4 states based on these 4 bits means? Strongly taken, weakly not taken, and strongly not taken. So here we have indicated all the 4 states. Okay. And next one is, if prediction is made, what happens? If branch taken, from which state to which state it moves, and if branch is not taken, in which state it will be present. Okay. So here, if when the history bits is in 1 1, if the branch is taken, it remains in the same state and downgrade to weakly taken. That means if branch is not taken. If the state is in 1 0, if the prediction is made, if the branch is taken, upgrade to the strongly taken state. If the branch is not taken, it downgrade to the weakly not taken state. So that is why here it is clearly represented whether it is in the same state or whether it is moving to the other state based on the prediction taken or not taken. If it is 0 1, if the prediction is made and if branch is taken, upgraded to the weakly taken state. If branch is not taken, downgraded to the strongly not taken state. Okay. So similarly, this is for the last state. So this is what about the features of 80486 and Pentium process and about branch prediction technique. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.